You've probably seen the hack scrolling through your feed, sandwiched between a 5-minute recipe and a DIY shelf. The promise is simple, almost seductive. Just throw your kitchen scraps into a grocery bag, tie it up, boom, instant compost. It taps into that desire we all have to do the right thing, to reduce waste, without needing a PhD in soil science or a backyard the size of a football field. It sounds incredibly convenient, it's practically free, and honestly, it sounds a little too good to be true. When something sounds too good to be true, that's our cue. It's time to test it, but we're not just going to test the plastic bag. To really understand what's happening, we need a proper experiment. So, we're setting up 3 contenders. First, the star of the social media hack, the classic plastic grocery bag. It's designed to hold things in, which could be a problem. Second, a standard paper grocery bag. It's biodegradable. But will it hold up? And third, a breathable fabric bag, to see if airflow makes a difference. We also need a control for our final planting trial, just good quality potting mix, so we have a baseline for what healthy growth looks like. To keep it fair, each bag gets the exact same diet, a carefully measured mix of kitchen scraps. We've got banana peels for potassium, used coffee grounds for a nitrogen kick, and a medley of vegetable trimmings. These are all greens in composting terms, nitrogen-rich materials. We sealed each bag and left them outside to face the elements for 4 weeks. I called it Compost, but I could feel the collective sigh of experienced composters everywhere. They know something we're about to find out. Composting isn't just rotting, it's a controlled process, a delicate dance of microbes, oxygen, and materials, and we've just sent our scraps to a dance with no air, no balance, and no room to move. Week 1 was uneventful. By week 2, things got interesting. The plastic bag started to puff up, trapping gases from the decomposing matter. The paper bag was showing dark, damp spots. By week 3, the plastic bag was visibly swollen, a balloon of anaerobic decomposition. The paper bag was sagging, clearly losing its structural integrity. And by the end of week 4, the plastic bag was tight as a drum. The paper bag had all but dissolved into a damp pile. This isn't composting, it's fermentation and putrefaction in a sealed environment. The lack of oxygen means anaerobic microbes take over, producing methane, hydrogen sulfide, and a whole cocktail of fragrant, volatile compounds. And now, the moment of truth. Opening the plastic bag was an experience. The smell that erupted was a potent, acidic, gut punch of decay. It nearly knocked me into a different reality. We are definitely not bottling that scent for our perfume line. This is the signature smell of anaerobic decomposition, rotting, not composting. The contents were a slimy, unrecognizable sludge. The paper bag had mostly become part of the mess, creating a soggy, collapsed pile. The breathable bag was less pungent and a bit drier, but still far from the earthy smell of true compost. But hey, plant nutrients don't care about vibes or smells. So, does this foul sludge have any redeeming value for our plants? We filled separate containers with the contents of each bag, plus our control planter with standard potting mix. We planted lettuce seeds in each one, no extra fertilizer, just our $0 compost versus a store-bought baseline. At first, the growth in the plastic bag container was surprisingly fast. Lots of leaves shot up, even faster than the control. It was a shocking flush of green, but as they grew, you could tell something was seriously off. The leaves were pale, the stems were long and weak. This is what gardeners call leggy growth. The plants were floppy and couldn't support themselves. What we're seeing is the result of a massive, unbalanced nitrogen dump. The anaerobic process made a lot of nitrogen available all at once, forcing rapid, weak leaf growth at the expense of strong roots and stems. It's like feeding a child nothing but sugar. You get a burst of energy, followed by a crash, with no real nutrition for long-term health. The control lettuce, meanwhile, was shorter, sturdier, and a much deeper green. So, did it work? It grew food, yes, but it wasn't premium food. It was weak and nutrient imbalanced. So, what's the real takeaway? If you want to make actual compost, you need 2 things this hack ignores: oxygen and a balance of materials. Aerobic microbes, the good guys, need to breathe. That's why compost piles are turned. You also need a mix of nitrogen-rich greens, like our scraps, and carbon-rich browns, like cardboard, dry leaves, or sawdust. This balance feeds the microbes and creates the beautiful, crumbly, earthy-smelling stuff that builds healthy soil structure. You can achieve this easily in a small bin with holes drilled in it, or even a simple pile you turn with a pitchfork. But here's the most important lesson from this slimy, smelly experiment. You don't need everything to be perfect to start growing. You don't need a 3-bin compost system that costs hundreds of dollars. This test proves that even a flawed process can teach you something valuable. It shows that there are nutrients locked away in your kitchen scraps, waiting to be used. You can build your skill and understanding long before you build the perfect compost pile. In gardening, and in life, effort always beats excuses. Curiosity always beats rigid rules, and the only real hack worth keeping is the one that encourages you to get your hands dirty and try things for yourself. So go ahead, experiment. Maybe just do it with a bit more oxygen than this. Stick around for more experiments, where we turn gardening myths into measurable results. If you enjoyed decoding this hack with us, hit that like button, share with a fellow curious gardener, and subscribe for more. Let's decode the dirt together.